Question 32. For a given risk, its risk level is $1,000 and its risk likelihood is estimated as 50%. What is the risk impact? In this example, risk level is $1,000. And risk likelihood, 50% or 0.5. In the quantitative approach, the risk level is calculated as the multiplication of risk likelihood and risk impact. Then, risk impact equals risk level divided by risk likelihood. So, the risk impact equals $1,000 divided by 0.5 equals $2,000. Thus, here the risk impact calculated is $2,000 and it indicates that if the risk event occurs, it would result in a financial impact of $2,000. Question 33. You are testing a simplified apartment search form which has only two search criteria. Floor, with three possible options: ground floor, first floor, second or higher floor. Garden type, with three possible options: no garden, small garden, large garden. Only apartments on the ground floor have gardens. The form has a built-in validation mechanism that will not allow you to use the search criteria which violate this rule. Each test has two input values, floor and garden type. You want to apply equivalence partitioning to cover each floor and each garden type in your tests. What is the minimal number of test cases to achieve 100% EP coverage? The minimal number of test cases to achieve 100% EP coverage are: 1. Ground floor with small garden. 2. Ground floor with large garden. 3. First floor with no garden. 4. Second or higher floor with no garden. These 4 test cases will cover all the equivalence partitions. The answer is B, 4. Question 34. You want to apply branch testing to the code represented by the following control flow graph. How many coverage items do you need to test? To determine the number of coverage items needed to test, we will count all the branches in the graph. Steps. First, identify the nodes and the edges connecting them, and then count the number of branches originating from each node. From node 1 to node 2, first branch. From node 2 to node 3, second branch. From node 2 to node 4, third branch. From node 3 to node 2, fourth branch. From node 4 to node 5, fifth branch. From node 4 to node 6, sixth branch. Thus, there are 6 branches to test. Question 35. You are testing a banking application that allows a customer to withdraw $20, $100 or $500 in a single transaction. The values are chosen from a drop-down list and no other values may be entered. How many equivalence partitions need to be tested to achieve 100% equivalence partition coverage? To achieve 100% equivalence partition coverage, first let us consider the valid partitions as $20, $100, $500. Since here no other values can be entered, due to the drop-down list constraint, we need to identify the equivalence partitions based on these values. And the invalid partition is no selection in the drop-down. So, the total number of equivalence partitions that need to be tested to achieve 100% equivalence partition coverage is 4. Question 36. Which test activity does a data preparation tool support? Options. A. Test monitoring and control. B. Test analysis. C. Test design and implementation. D. Test completion. The correct answer is C. Test design and implementation. Explanation. A data preparation tool supports test design and implementation by helping testers to create, manipulate, and manage test data that is necessary for executing test cases. These tools facilitate the setup of the required test environment and ensure that the test data is accurate and relevant for the scenarios being tested. Question 37. A developer was asked to implement the following business rule. Input. Value. If value is less than or equal to 100 or value is greater than or equal to 200, then write value incorrect. Else write value okay. You design the test cases using two-value boundary value analysis. Which of the following sets of test inputs achieves the greatest coverage? It is understood, the numbers from 101 to 199 represent value OK. This is two-value boundary value analysis. So, the valid boundary values are 100, 101, 199, and 200, given in blue color. Let us analyze the options. The options A, B, C doesn't have any valid boundary values, but have only invalid boundaries. The option D has both valid and invalid boundaries. Invalid boundaries are in orange color. Question 38. You are testing a mobile application that allows users to find a nearby restaurant based on the type of food they want to eat. Consider the following list of test cases, priorities and dependencies. Which of the following test cases should be executed as the third one? Let us understand the dependencies and priorities. It is understood, test case 3 has priority 1, but depends on test case 2. At the same time test case 2 depends on test case 1. So, first execute test case 1, with no dependencies. Then, test case 2 with priority 2. Next, test case 3, with priority 1. The other test cases depends on test case 2. So based on priority they can be executed. Now, execute, test case 4 with priority 2. The last one is test case 5. Question 39. You are testing a thermostat for a heating, air conditioning system. You have been given the following requirements. When the temperature is below 70 degrees, turn on the heating system. When the temperature is above 75 degrees, turn on the air conditioning system. When the temperature is between 70 and 75 degrees, inclusive, turn on fan only. Which of the following is the minimum set of test temperature values to achieve 100% two-value boundary value analysis coverage? To achieve 100% two-value boundary value analysis coverage, let us break down the boundaries. And the boundaries are given here. From these boundaries, we can get the minimum set of test temperature values to achieve 100% coverage as just below 70 degrees, 69. At the lower boundary, 70. At the upper boundary, 75. Just above 75 degrees, 76. A company has set up an employee wellness program and combined it with the payment for health insurance. The program has the following rules. 1. Employees who consume 0 units or less of alcohol per week get $50 off their payment. 2. Employees who consume 20 units or less of alcohol per week get $25 off their payment. 3. Employees who consume more than 20 units of alcohol per week get $0 off their payment. The developer made a mistake in the third equivalence partition. Instead of number of units is greater than or equal to 21, developer coded number of units equals 21. Using boundary value analysis, which of the following sets of test inputs will identify the problem? Here the correct boundaries 0, 1, 20, 21 units. Let us write test cases, with the effective test inputs are 0, 1, 19, 20, 21, 22. So, 0 units get $50 discount. 1 unit, 19 units and 20 units get $25 discount. 21 and 22 units $0 discount. You are testing a machine that scores exam papers and assigns grades. Based on the score achieved, the grades are as follows. 1 to 49 equals F, 50 to 59 equals D minus, 60 to 69 equals D, 70 to 79 equals C, 80 to 89 equals B, 90 to 100 equals A. If you apply 2-point boundary value analysis, how many test cases will you need to achieve minimum test coverage? First, identifying boundaries. 1 is lower boundary, so take 0, below 1. 100 is upper boundary, so take 101, above 100, these two are invalid boundaries. As well, the other valid boundaries are identified as 1, 49, 50, 59, 60, 69, 70, 79, 80, 89, 90, 100. So, we need 14 test cases to achieve minimum test coverage.